This short video is going to take you through using the Avogadro constant as a conversion factor. So the Avogadro constant is given the symbol N subscript A and is used to convert between chemical entities and an amount in moles. Chemical entities in this context of chemistry is most commonly a number of molecules. So that's something that's covalent bonded. A number of formula units, so that's something that is ionically bonded. Could refer to a number of ions, either simple ions or polyatomic ions, or it could simply refer to a number of atoms. So the Avogadro constant is 6.02 times 10 to the 23rd entities per mole. Now remember, you don't have to memorize this. You just have to know how to use it. You will always be given that number on a test or an evaluation, but you do need to know how to use it as a conversion factor. Just to remind you, entities dot mole to the -1 is the same as saying entities per mole, and that's shown here. And N, the symbol N, is referring to the number of moles. So let's carry on. So, as a typical conversion factor, the Avogadro constant can be used in one of two directions. That is, it can be expressed one of two ways because it's a number with a fractional unit. And so that, therefore, we can use it to calculate two different things. So the first thing we want to be able to calculate is the number of moles. And if we want to calculate the number of moles, we must be given the number of entities. In this case, molecules. So if you're given the number of entities, you can calculate the number of moles using the Avogadro constant. Number of molecules divided by Avogadro's constant gives you a number of moles. And this number should be small. And that should make sense. Number of molecules is going to be huge. We divide it by a huge number, we get a small number. And that's what you're trying to do. Get it into that number of moles, a small number we can handle. The other thing you can do is calculate the number of atoms. So if you want to calculate the number of atoms, you must be given the number of moles. And if you're given a number of moles, it's a pretty simple calculation. Number of atoms equals number of moles times the Avogadro constant, Na. And this number should be huge. And it should be huge because you're going down to the chemical level, that submicroscopic level, that level of those tiny molecular atomic entities that we cannot see individually. So let's try a calculation. Here's one. If we have 7.75 times 10 to the 24th atoms of oxygen in a sample, how many moles is that going to be? Well, here's the Avogadro constant given to us, and here's our equation. Number of moles equals number of atoms divided by Na. So 7.75 times 10 to the 24th atoms divided by 6.022 times 10 to the 23rd atoms, which are entities, per mole. So atoms divide out, you're left with 1 on 1 on mole, which is the same as mole, and we have 12.9 moles. Well, there's another way to use this Avogadro constant, that's as a conversion factor. So if you remember from dimensional analysis, number of moles is what we're looking for. That equals what we're given, which is atoms, times a conversion factor. And in this case, our conversion factor is going to be the Avogadro constant. We're going to express it in such a way as to do the correct unit analysis. So 7.75 times 10 to the 24th atoms times, now we want to get rid of atoms, so we're going to put that on the bottom, and on the bottom is our Avogadro constant number, and that's 6.02 times 10 to the 23rd atoms, and what we have on top is 1 mole. And so you know, as atoms divide out, we're left with the unit of mole on top, which is what we want, and we actually get the same answer because it is still dividing 7.75 times 10 to the 24th by 6.022 times 10 to the 23rd. So that's another way you can always use a conversion factor, and that's when conversion factors with fractional units can be expressed always one of two ways: atoms per mole or mole over atoms. Well, here's another quick calculation, just doing the other order. How many formula units of sodium sulfide are there in 2.25 moles? So again, there's the Avogadro constant. So number of formula units is what we're looking for. And that equals what we're given, which is moles, times the Avogadro constant, Na. So we have 2.25 moles times 6.022 times 10 to the 23rd entities, which in this case are formula units, per mole. Moles divide out, and you're left with 1.35 times 10 to the 24th formula units. And so that's going from a small number, n, to a great big number, formula units. And again, that should make sense to you because number of moles is small typically at the atomic level, that microscopic level. We have many chemical entities. We'll just extend that a little bit. Okay, so we already found out how many sodium atoms there were in 2.2, or we already found out how many formula units there were, but how many sodium atoms would be in 2.25 moles of sodium sulfide? Well, we already figured out that there were 1.35 times 10 to the 24th formula units of Na2S. And we can see that there are 2 sodium atoms per formula unit. So to determine how many sodium atoms there are, we simply take what we already know and we multiply by a conversion factor. And so the conversion factor is shown here, that 2 atoms, sodium atoms, per formula unit. And again, if you notice what divides out, formula units now divide out, you're left with the unit of atoms, and we have twice as many atoms as formula units, which makes sense because we have 2 atoms per 1 formula unit. And that's how we use the Avogadro constant.